Hi, I'm Naina Manori, working as Assistant Professor in the Department of Civil Engineering, SVIT Bangalore. I'm the course coordinator for Design of Pre-stressed Concrete Structural Element. Module 1, Analysis of Stresses. Okay, that too by pressure line concept. A pre-stressed concrete beam of section 120 mm wide and 300 mm deep is used over an effective span of 6 meter to support a uniformly distributed load of 4 kN per meter, exclusive of self-weight. The beam is pre-stressed by a straight cable carrying a force of 100 kN and located at an eccentricity of 50 mm. Determine the location of thrust line in the beam and plot its position at quarter and central span section. Okay, first that is solution. First you calculate the effective span they have given, that is 6 meter. The cross sectional dimension they have given 120 mm wide and depth it is 300 mm. Okay, the span it is 6 meter. To support a uniformly distributed load of 4 kN per meter. Okay, that is live load they have given, that is 4 kN per meter, which is what, exclusive of the self weight. Then the pre-stressing force they have given, that is 100 kN. It is a straight cable. Eccentricity they have given, that is 50 mm. Okay, first you calculate dead load of the beam. Dead load of beam, that is 0.12 multiplied by 0.3 multiplied by 1. Okay, take the density as 25 and you will get a dead load as 0.9 kN per meter. Okay, and the live load they have given, that is 4 kN per meter. Then calculate total load, that will be equal to 4.9 kN per meter. This is what, total load. Next you need to calculate the moment. Okay, see, first write down the load diagram. Okay, the total intensity of the load, it is 4.9 kN per meter. Okay, the span of the beam, it is 6 meter. Okay, once you draw the load diagram, you need to calculate the reaction, that is the support reaction. It is what? The beam carrying UDL, the support reaction value, it is W by L. Calculate that value, that is WL by L, it is 4.9 into L value, it is 6 divided by 2. Then you will get it as 14.7 kN. This is what, the reaction. It is a symmetrical load. The reaction at A and B are equal. Then you need to calculate bending moment value. Okay, that is BM. I will denote it. Okay, then calculate at each point, that is bending moment value at the mid span as well as at the quarter span and at the end support. Okay, that is moment at end support will be 0. That will be equal to 0. Then moment at C and D, it will be equal. Take bending moment value, moment of all the forces either towards left of C or the right of C. Due to symmetrical, the moment at C and D, it will be equal. That is MC equal to MD, that will be equal to. Take moment about left of C. Whatever all the forces are acting, take moment of all the forces about C. First is what, RA, it is rotating clockwise. It is positive. That is 14.7 into 1.5, it is clockwise, and this UDL, it is rotating anti-clockwise, it is minus 14.9 into 1.5 into 1.5 divided by 2. Okay, then calculate MC equals to MD. Upon simplification you will get it 16.53 kN meter. This is what, MC as well as MD. Similarly, you need to calculate moment, bending moment at the mid span, that is M naught. That will be equal to what? Bending moment at the mid span, you know that standard equation, or you can use same as it is, taking moment of all the forces towards left of O or right of O. because it is a beam carrying UDL throughout the span. At the midspan, the equation I will write it directly, that is the standard equation I will be using, WL square by 8. W value it is 4.9 into L value it is 6 square divided by 8. Upon simplification, you will get it 22.05 kilonewton meter. Next is what? Pressure line location. In order to calculate the location of the pressure line, that is eccentricity, at what particular distance it is acting, that pressure line, at the support as well as at the midspan and the quarter span, that can be calculated by using that equation, that is E bar that equal to M by P. M is what? Moment. P is what? The pre-stressing force. Okay. For that load diagram we wrote it. For that particular beam, you need to calculate the pressure line value at each point. As such of what? Bending moment value calculated, right? Same as such, you need to calculate a pressure line location also at each point. Okay, that is eccentricity at A, that is E dash A, that will be equal to EB dash, that will be equal to what? Moment value is 0. Okay, then this E dash value will become at the end support it is 0. Next we have calculated E dash at C as well as E dash at D, that will be equal to moment value is, that is 16.53 kilonewton meter. Substitute in mm, it is 10 to the power of 6 divided by P value it is 180 kilonewton, that is 180 into 10 to the power of 3, you will get it 91.83 mm. Similarly, calculate E dash at midpoint, that is O, it is given by M by P, that is at midpoint moment value is 22.05 into 10 to the power of 6 divided by P value 180 into 10 to the power of 3, and you will get it as 122.5 mm. Okay, you can observe all the eccentricity value, it is positive. Positive means show the pressure line above the neutral axis. So this is the pressure line diagram. This is what the section of the beam. Okay, this is the red line indicate, that is what? Neutral axis. Below the neutral axis you are going to place the tendon here. Okay, that is the cable. Okay, see, this is the support point A as well as B. The eccentricity value it is 0. Okay, you can observe here, that is A as well as B. Okay, this is A and this is B. This is C, D and this is O. Okay, at A it is 0. That is eccentricity value at the support it is 0. Eccentricity at C and D it is 91.83. See here, I have shown it here. Okay, and at the midspan O it is 122.5 mm. Then join that curve, okay, smoothly, okay, and show that height value. Okay, this line you call it as what? That is pressure line. Okay. Thank you.